All right, so we finished like that unit testing one, and remember, like I was saying, the unit testing that we were doing is for a very simple class. We're about to start making a far more complex class. It's more complex. It might seem, after we're done this, you might say like, well, that's really not too bad. It's not that it's bad, it's that it is absolutely more complex. There's a lot more going on with it. It's very stateful, therefore it's very mutable. There's a lot going on, meaning it's a lot harder to manage and keep track of the data and everything. So it will also be harder to test. But we're not worrying about the testing right now. That'll be like some subsequent topic. Right now, we're talking about making a data structure. Okay, we're going to make we've got our friend class, right? How much of this did we do already? I don't think much. We've got our friend class, and we want to keep track of our friend object. So we're going to make a contact list. Because remember, this was the whole point of the exercise. We're making a contact list, which is effectively going to be like a list of friends. But it's specifically designed to manage our friends. So what fields are we going to need for this class? Well, we're going to need some sort of like some form of a container. Something to actually put the friend objects in, right? Now, in Python, we were used to lists, but we don't have lists here. We have something similar-ish, arrays. So we're going to use an array to store the friends. But we know that arrays are funny in that, like, when you make a list in Python, it could be empty and you keep adding to it, whatever. Arrays don't work like that. When you make an array, you need to specify some, like, capacity. How big is it? You know, when you make an array, it'll be like empty, but it'll still have like a set number of seats in it, right? Like this room has like 50 chairs in it, but no one's sitting in it. I mean, now there's people sitting in it, right? But that's what I'm getting at there. So we've got an array, so we need to make some array, and we also want to keep track of how many friends do we have in our contact list. And you might say, well, isn't that the length of the array? No, because the length of the array is the capacity. How many friends could fit in this array, but how many friends are actually in that array? So this room has a capacity of like 50 seats, but how many students are actually in here? That's the difference. So we're going to keep track of the count of the friends, and we're just going to hold on to this in some integer. But the array is going to be an array of friends, or a friend array. So here we go. We've got some imports here. We've got this objects. That's, you know, if you remember, that's where we store a bunch of static methods for objects. This no such element exception, that's, you know, we'll use that later to throw an exception in a special case. More on that to come. And this arrays thing, we're going to make use of this again later. Not overly important right now, but we've got some imports. Here is the start of our class, public class contact list. So obviously this is in a file called contactlist.java. And we start with two variables at the top. But we're going to skip them for a moment, and we're going to jump down to the next two on line 15 and 16. Int size, that's going to be the count. How many friends are actually in my array? And then the next thing is going to be a private friend array. I know it's an array because we've got the square brackets. And I know it's a friend array because it says friend right there. And I call it friends because why not? I could have called it the list. I could have called it widgets. It doesn't matter. I called it friends because it makes sense. It's an array of friend objects, right? So friends, why not? Now, going back to these two, the first one is private static final int. Well, what's going on there? Well, first, it's a private value, meaning I shouldn't be able to access this variable outside of this class, and that's fine. Okay, great. Static means this is a value that doesn't belong to any specific instance of a contact list. It's just a value that exists within this class, but it doesn't belong to an instance of this class specifically. All right? We'll come back to this. It's final, it's a constant, it's set here, and we're never going to change it. It's an int, and it's called default capacity. We're following that convention, uppercase with underscores. Private static final int not found. Now what's going on here? We had this idea last semester. This is a sentinel value. Remember how, like, if I said write a linear search to tell me the index of where something exists inside the list, right? And then the question comes up like, okay, so if it's an index 0, return a 0. If it's an index 7, return a 7. If it's at index x, return x, right? What if it's not there? What do I return? Well, then we can return a sentinel value. And we usually, in a case like that, we would return -1. Why -1? Well, in the context of this problem, -1 would mean that it wasn't found. This find function, this linear search function's got to return an integer, an index. So I got to return an integer, but it needs to be a special value that has special meaning in this context. -1 means, to anyone using this, it's not found. But of course, the value -1, I mean, that's great and all. Someone could probably figure out what it means. But one of the good uses of constants is to give a special value a name. So I could just say not found. Return not found when it's not found. And you say, well, yeah, but not found really is -1. Exactly. It's just to give a name to a value. That's all. It makes your code more self-descriptive. That's all. But the default capacity one is a little different. The not found, whatever, it's a static value. Can you see how, like, this value not found, it doesn't need to, like, there's no sense in you having a not found and you having a not found value associated with yourself or you. You all have first names. They're about you. But not found, you know, it's just this value that needs to exist. And why do we put it in this class? Because we're going to use it in this class and it'll be helpful in this class. But it doesn't belong to any instance. In the same way, the default capacity that we're going to use very soon. Every one of you knows about this default capacity, but there's no sense in you having like a field associated with yourself that's like, yes, this is my default capacity. No, you all have the same default capacity. It doesn't have the same spirit of like, what's your first name? What's your last name? What's your height? You see what I mean? So that's why they're static. Now here we have two constructors, and I'm doing something kind of weird. I'm kind of throwing you into the deep end with this example. But let's start with the second constructor. When I create an empty contact list, okay? Pause. When I make a friend, the friend should have a first name, last name, and so on, right? And an email address. That's what we were doing. So I give those values to the constructor. This object, though, that I'm making is very different. When I make a contact list, what should its values be? Well, it should start empty, right? So, I mean, I'm giving it this initial capacity. What's going on here? Well, I'm going to make a contact list, and I'm going to say, like, how would I use this? Okay, make a contact list with an underlying array of size, whatever I give it, right? Maybe it's like 50, whatever. Meaning I've got an array with 50 spots in it. I could put 50 friends in there. Easy peasy. But what is its size at this stage? 0. It's empty. Don't get, at this stage, so many people are like, but there's a field size. I need to give it to the constructor. No. No. Don't connect that. There's no connection there necessarily. There might be, like, create a student or create a friend object. First name, last name, email address, right? Yeah, that makes sense. Here, create an empty contact list. What should its size be? 0. You don't need to tell it its size is 0. When you create it, it's empty. Its default size is 0, right? So just set it to 0. That's what we're doing here. So contact list, we give it an initial capacity. So if we were to say like 50, I call the constructor contact list 50. So what is it going to do? Well, size gets set to 0. And friends is equal to new friend array of size initial capacity. Questions about that? Now you might say, well, how do I know how big I want my capacity to be? Well, maybe you do know, maybe you don't know. Maybe in your mind you're like, I don't know, I got like, I've got like 20 really close friends I want to keep track of, and I'll give myself some extra room. Let's make it 50, whatever, it's fine. Why, I just came up with a reason to make it 50. It's not overly important how big I set it to, but I can set it. But let's say you're like, well, I don't know. I don't know. I have no idea how big I want to set it. Okay, well in that case, what we would do is we could make use of that default capacity, where if you don't specify how big should the array be, we make use of default capacity. But we're going to do this in a very interesting way. We're going to do this using something called constructor chaining, which is kind of advanced, I guess. So I'm kind of throwing you in the deep end with this concept. But what this means is, if I ever call, so first of all, we are doing this idea of overloading, which is something we don't do in Python, but it's something we can do in Java. When you have a method with the same name, but different parameter sets, this is called overloading. So I have a method, the constructor, contact list. I have another one, contact list. They have the exact same name, but one takes an integer and one takes nothing. If I call contact list and give it no arguments, it's going to call the one that has no arguments. If I give it an integer, it's going to call the one that takes an integer. If I give it a string, it's going to crash because there is none that takes a string. So that's what's going on here, constructor chaining. So what does this mean? If I don't specify, I immediately say this. Well, let's go this open parenthesis. When I type it like this, it means call the constructor that takes one integer, because that's the type of this here, meaning it just calls this ultimately. So it calls this one by automatically giving it the default capacity. That's what it's doing. And if you're like, why is that the syntax though? Because somebody somewhere said that's the syntax and I had no control over it. Don't get mad at me. All right? I'll give you another example of, let's go to main here. Overloading. Static int add int a int b. All right, return a plus b. All right, looks good to me. And then static double add a. Okay, cool. So here, I've got two add functions, static methods. And you're like, but they're the same. Yeah, but no. Yes, they do the same idea, but one takes two integers and one takes two doubles. So if I say add 5 and 0, well, it's going to call, which one of these two is it going to call? The int one, obviously, and so on. So like this would be overloading. And it's smart enough to know which one to call based on, well, what did you give it? It's just going to play the matching game. Two integers? Two integers. Great. Other questions about what we're seeing here so far? All we see is a couple of imports, whatever. We're defining the class, two fields, but we have these two constants that I guess are static values. Okay, new idea, but okay. And constructors, but again, we're doing that constructor chaining, which is a new idea, but it shouldn't be too bad. It's called chaining because this one just automatically calls this one. That's all. All right. Okay, the imports, two constants declaring the fields, two constructors. Most of the ideas should already be familiar with. The imports are used, whatever. One constant, it defines the default array size. More on this below. Not found, it gives a name to the sentinel value -1. The declaring of the fields is similar to what we've seen in the friend class, right? Except we use them a little differently here. Having the two constructors is a new idea that we didn't need in Python. That's because Python, you can put whatever types you wanted, right? So you can just kind of do whatever you want. And in Python, you could also have like default values, which kind of helps with your parameters. Remember how you could do that in Python? It doesn't matter. Whatever, you could. Do you remember how like in Python you could say like def sum method a, b, but equals like 10, right? Remember how you could do that? And then it would be like return a plus b. And then if I call this method, I could only give it one argument. And if I did, it would go like, okay, well, what did you give me? And then add b, which is 10 by default. But if you do give it two arguments, it overwrites whatever was default. We don't do that in Java, but you could do that in Python. So this would kind of be like imagine this was the constructor for it's kind of like doing that. That's what we're doing with the constructor chaining, is if I don't give it anything, use default capacity. If I do, then use whatever I give you. Yeah?
Can you still use constructor chaining in Python? Or is that
I think it would be like a Java thing. I don't believe so, no. Okay, notice that the constructor takes no parameters and the other one takes a single one. For now, focus on the second one. It sets the size field to 0. Why? Because every time we make a new contact list, how many friends are in it? 0. We don't need anything more than that. I said it already, I'm going to say it again. Don't get caught up thinking like, I've got 3 fields, my constructor needs to take 3 arguments. No, absolutely not. No. Sometimes they do, sometimes they don't. There's no dots to connect there. There's nothing more meaningful than that. Consider, okay, remember arrays have a fixed size. Strategy here is to make an array that is sufficiently large, but only use what is needed. Consider the following example, an array of size 10. Only 2 friend objects are added, so then only indices 0 and 1 are used. And the size would be like 2, right? We've got an array, we've got 8 extra seats, but that's fine, whatever. We wasted some space. Space is cheap for us. The second constructor, the one that takes an integer, is used to create a new contact list with the array of some specified size. The first one that takes no parameter, this is the constructor chaining thing here. Okay. So here would be an example of saying, like, this is what we would get. If I were to go to like my main and say contact list contacts equals new contact list 5. If I were to type that in, this is what I would get. I mean, really, this array here shouldn't even be in this circle. It could be somewhere else. It's not really contained in the circle, but I'm kind of showing it here to show you that it belongs to it. But it's not really in there. It doesn't have to be. I've got a reference variable to a contact list called contacts. It references this object. This object has 2 fields. Friend count, I called it size, but here I called it friend count, whatever. And it's got a size of 0. And a friends array, which is an array. That array exists, but nothing is in it. And it's size 5. Why is it 5? Well, because I put the 5 there. I said it was 5. Right there. So 2 methods we could add immediately. Public boolean is empty and public int size. Now, let's talk size first. So first of all, because this came up yesterday, I'll say it again. The order doesn't matter. If you're like, but you're using size before it's declared, it's fine. Java, it's entirely fine like that. It does 2 passes. It does the first pass to be like, when Java looks at your code, it goes like, does that exist? Oh yeah, it exists, whatever. It just makes sure everything's there, and then it actually builds. So it's okay. That second one there, size. So first of all, you might say, well, hold on, size was a field, and all of your accessors for your fields were get size. Yeah, but I'm just calling it size here because that's a good name for me, right? It's a function, or it's a method, and all it does is return the value size. If you're thinking, why not make size public? Because then someone would have direct raw access to that field. And they can go and be like, contact list size equals 77. But that makes no sense. There's no 77 things in my contact list. No one should have control of updating the value of size except the class itself. That's why it's private. You can get the value. I can say, hey, size is 2, but I never give you direct access to this. I still have this. I can tell you its value, but I never give you access to the field. I can give you access to the value, but not the field. Okay? It's key. And then is empty. I call the method size equals 0. Couple of things to note here. You might say, why call the method size and not just access the field size, right? Why not? You're right. It doesn't really matter. For me, when you are given a choice, use the methods, because all the public methods are like how one would use this class. So like we know they're good. At the end of the day, it doesn't really matter. But I'm using the method size, which just returns that value. And you might be like, you can return like this function. No, don't get confused here. Size returns a size. It might be 0, it might be 100. And then it checks, hey, does the value equal 0? If it is, let's say size returns 0. 0 equals 0 is true. What do we return? True. If it's not 0, then this is not true. We return false. So don't think too hard. Just that's a Boolean expression that gets evaluated and returns a Boolean, as this function expects. All right? I could have, if this was Python, I would have to have something like self.size here, right? Same with accessing size. I would need to like self.the field size. In Java, I can say this dot. I could do that. If you like that, by all means, go ahead and do it, but it's not necessary. Java knows what you're talking about in that case. Any questions now? Ask now before it's too late.
Because you like said public Boolean, does it like when you're returning it, does it know to return a true or a false?
Let me put it this way. If it didn't, it wouldn't compile. So it's like, hey, okay, this is a Boolean. This function, whenever it gets called, it's got to return a Boolean. And if you tried to like return an integer, Java wouldn't even compile. It would be like, no, you said this was going to give back a Boolean, but you're trying to give back an integer. No. So that's what's going on there. Which is cool. That's a good thing. We don't want incorrect code to run. If you really wanted it to be an integer, then make it an integer, right? Don't say it's a Boolean and then be like, but I want it to be an integer. So isEmpty returns a Boolean. Size just returns the size. Okay, add. So this is assuming empty is size. We have to have a way to add something. We're also going to want a way to remove something and maybe check if something's in there. All common stuff you might want to do with a contact list, right? So let's do add. Now, this is a bit of a complex method here, because arrays have a fixed size, and the capacity of the array is not the same as the number of friends in the collection. And since arrays have a fixed size, it's not possible to add more friend objects beyond the size of that array. If I'm going to make an array of size 10, and I try to add an 11th friend, it's not going to work. There's no room. It's not going to work. So we have a decision to make here. What do we want to do? Well, one thing we could do is say, okay, if someone tries to add a friend beyond the capacity, don't let them. It is what it is. You said you could have 10 friends, you try to add an 11th, you can't do it. It just add will do nothing. Ignore it. It does nothing. We could do that. Or we could add it anyways somehow. Like think back to the list object in Python. As far as the computer's really concerned, if you open the hood under there, when you're using the list, you can keep adding forever. Now, do you think a computer really is happy with that? No, it's not. Under that list, there's going to be a finite size, and yet you're somehow magically able to keep adding forever and ever and ever and ever and ever. But it's because Python's doing a little bit of work under the hood. And we can do the exact same thing. we can hide some of the bookkeeping and shuffling around we have to do to like be able to add things indefinitely from the person using my object, just like the list class did in Python. Python, under there, the list has a fixed size, and yet you could add forever. What's going on? So here's what we can do, is let's say I have an array of size 5. And in my array of size 5, I have references to 5 objects. Okay? 1, 2, 3, 4, 5. Ignore this bottom part for a second. This is what I have. There. And I want to add one more thing to this list, right? Or this array. I can't do it. So what I do is I say, okay, don't add it yet. Make a new array that's bigger. I'm calling it new friends here. Copy over all of the references from the old array. Okay? And then set the friends reference variable that referenced that array that was size 5. Have it reference the new one. Then add it. That's what I'm going to do. And all of that functionality is hidden from the person using the contact list. This right here, that's what Python was doing with the lists. But did you know that? Did you have to know that? No, you could just add. So if you ever called add, and under the hood you're out of space, Python would do something like this. But did you care? No, you didn't. And that's a good thing. It didn't matter to you. So here's add. Let's ignore this first part right here for a second. Add. How do we add something? Well, friends at index size, what's going on there, is equal to the friend. So, okay, let's start for a second. Public Boolean add, and it takes a friend. Presumably this is the friend we want to add. Okay? Add returns a Boolean. Now, this isn't strictly necessary, but is a common pattern in Java. Whenever making a collection, something like a list or something similar, your adds and removes often return a Boolean, true, false, depending on was the add or remove successful or not. That's a common pattern. So when given the choice, follow the common pattern that the language follows, right? So we're going to have it return a Boolean. Friends at size, like what's going on there? Well, more on that in a second. But imagine I magically know where to put the, okay, no, let me put it like this. Let's draw it. I've got an array of size 5. There's nothing in it right now. What is its size right now? That shouldn't have been a trick question. You should have known that one. There's 0 things in there. Now, when I add something, it's empty. When I add something for the first time, where should it go? The beginning, right? And what value, which index is the beginning? 0, right? In fact, okay, 0, 1, 2, 3, 4. So I put something in there, and now size should now be 1. Can you see that over there? Perfect, right? Great. So let's say I want to add something again. Based on its current state, where should it go? Which index? 1, right? Yeah. And then size gets updated to be 2. If I add something again, where should it go? And then, okay, we increment that, right? Have you noticed a pattern? If you haven't, wake up. It's pretty obvious. What's the pattern? Yeah, well, that's what we're doing. But look, size, and this is by virtue of the fact that we have zero-based indexing, right? Size is 3. Where would the next friend go? In index 3. The next available spot is always size. Whatever value size has is always the index where the new thing should go. And this is by virtue of zero-based indexing. Because of that, when I say zero-based indexing, I mean we start at 0, not 1, right? So size conveniently always has both the size and the index where the next thing should be for a list like this. This is not always true for a general collection, but for a list like this, that's the case. So that field, size, is kind of doing double duty here, which is pretty cool, right? All right, so that's why whenever I want to add a friend, I go to, okay, friends at index size is equal to the new friend, increment size, return true. Why return true? Well, we have to return a Boolean, and we return true whenever adding was successful. So we return true. So what do I do, though? Because I just before this, I put a whole spiel about the fact that we might run out of capacity. That's what this check is here. What if the size is equal to the length, right? If I have an array of size 10, okay, its capacity is 10, and there are 10 things in there. What is the last index? Let's go back with this. How many friends? How many friends are in this array? 5. Okay? 0, 1, 2, 3, 4. Its size is 5. If its size and capacity, because remember, the length is always 1 more than the last index, or the last index is always 1 less than the length, right? So if the capacity and the size ever match, we're out of room. That should be clear. If it's not, you definitely can figure it out by this stage, right? Because if I try to go, okay, add something at index 5, well, that doesn't exist. I can't do that. So what do I do? Well, like we said, we could just disallow it and say return false. If we're ever out of room, return false. There, it fails. Great. And then if I call add and I ever see if I ever get a false back, I know it was unsuccessful. Okay, whatever. But we don't want to do it that way. We want to be a little bit more creative. So instead what we're going to do is we're going to say friends equals expand capacity. So what's all that about? Well, let's have a look. Here's expand capacity. Expand capacity takes a reference to an array of friends. This will always be like the friends field. I could have made this with a side effect. I didn't want to. More on that in a moment. So it takes the friends array. This is the old one the one I want to expand. I'm not really expanding anything. The array size is fixed. I can't do anything about that. But what I do is I make a whole new array that is always twice as big as the old one. And there's some nice mathematical properties why we always want to double. We'll talk about that a little bit more later. Not overly important for us right now. But we're going to make a new array that's just twice as big as the old one. All right? We're out of room. Make a new one. How big? Twice as big. Double the size. Yeah.
Would it be more efficient to create another one that's one larger than the other one and then delete the old one?
Nope. Absolutely not. And we'll learn why more a little later. So we make a new array that's twice as big. Then what we do is we have a for loop that goes from 0 to the length of the old array. We could have done to size, because the size and the length of the old array must be equal if we ever call this method, right? And if you're like, wait, how do I know that? Because this method will only ever be called from here, if this condition is true. So if this condition is true, then that condition is true. So I could have said size, but whatever. The reason I said, this is an example of like where programmers get really nerdy about their code. And if it's like, well, I could have said like size, or I could say old arrays old friends.length. Why did I say old friends.length? Because it's like the spirit of what the code is doing. What is this code doing? I want it to iterate over the entirety of the old array. So old array.length is a little bit more clear. Even though dot size is the same thing, you kind of have to make like another logical step. So that's why. Not overly important, but there was method to the madness there. Anyways, a for loop from 0 to the length of the old array. New friends at index I equals old friends at index I. That's this. Take this, put it there. Take this, put it there. Take this, put it there. This, there, loop's done. That's what we're doing. And then what do? The last thing we do is we return the new friend array. Really, we return a reference to the new friend array. So we return a reference to this right here. And then if we go back to where it was called, we return that reference, and then the field friends now references that new array. And then what do? We carry on as if everything's normal. Friends at index size, friend, increment size, return true. No matter what, this is what we're doing, but we might need to expand capacity before we do it. And the person who ever called add would be none the wiser that they ever had to call expand capacity. Maybe it did, maybe it didn't. Does it matter to me? No, I don't care. I just want to be able to add friends. That's all. Cool, right? I think that's pretty cool. What an easy way to eliminate the whole, like, oh no, arrays are fixed size. Yeah, but you get around it pretty darn easy. All right, so okay, to expand capacity. If the arrays in a from expand capacity is not called, either way we add. Yeah. I'm not going to pretend this is trivial to understand. It's not overly complex, but I'm not going to say it's trivial. So if you have a question, ask now. Yeah?
I'm having a hard time understanding how you slotted in, like, the indexes from the old, I guess you would call them old friends, into the, like, new friends.
So remember that arrays, regardless of what they're storing, there's some information inside each cell of the array. Okay? Whether that thing is a primitive type like an integer or a reference, there's something in there. I have A, B, C, D, E. Okay? That's what I have. And let's go back to the for loop here. All right? I've got a new array that's twice as big. Okay? First time through the for loop, I is 0. I take the contents of this one and copy it and put it into this one. This is the new one. This is the old one. Right? I take the contents of the old one in index I, which is 0, which might be an integer, might be a reference to an object, whatever, and I put it here. A. Copy it, put it there. B. Copy it, put it there. Copy it there. Copy it there. I'm done, and size is 5, whatever, it's fine. That's all we're doing. So how is it getting it there? Because I said in the for loop explicitly, go here, take index 0, put it here. Increment I, here to here. Increment I, here. Is that helping you?
Yeah, I'd say so.
Are you sure? Your face doesn't make me think you do.
Well, my face is always confused. So,
Oh, okay.
yeah.
Well, what were you going to say?
When it says new friends at index I and old friends at index I, does it like make the rest equal null because there's none?
By default, it's all, whenever you create a new array of objects, the contents of those array, when you create it, are null. So there's nothing in here. Null. That's why.
Is the fact that the old one doesn't have those like indexes affect those
I'm not sure I understand, because the old array only has 5 spots. None of its contents are null.
Would it iterate over the new one?
I'm iterating old friends.length. I will only ever go to the end of this one. I'm done. There's nothing more to do here. That's why. Is that answering it? Cool. Cool. And then this returning new friends. That gets returned. The new friends, well, the friends is there. Remember, old friends is just an alias for friends, because that's what I passed to it. All right. Now contains and find. Well, contains, let's do find first. Just a linear search. And please tell me you're happy with linear searches, right? What are we going to do? Well, I've got a friend. This is the friend I want to find. I can't use sameness because remember, equality and sameness are different things. I can make a new friend object with the same values that is equivalent to another one. I want to find Bob Smith, right? I don't have an alias to Bob Smith, but I've created a new copy of Bob Smith, and I want to check if they exist in here. So what am I going to do? Well, first of all, notice that this is private. I could make it public, but you know, the way that anyone interacting with this class, like no one's going to index this contact list, right? All I'm ever going to do is like print out its contents. So no one's ever going to index it, meaning no one really needs to know the index of any individual person. I could let them know that, but there's no need for them to know that. All this class is going to do is I can add friends, I can remove friends, and like print out my friends list. That's all. So there's no need for anyone outside of this class to know the index of these friends. Again, I could make it public and I could tell them that information, but there's no utility in it. The utility of this is going to be for within the class. So I'm making it private. So linear search, from 0 to size, the array could be size 1 billion, but if there's only 20 people in there, I only need to look at the 20, right? Right? So for however many things are in there, check. Hey, objects.equals, and remember, this is the null safe version. So that's why we're doing objects.equals, it's null safe. Do we have to do that here? Not really. Should you? Yeah. So objects.equals is the friend I'm looking for equal to the friends at index I, the current friend I'm looking at. If it is, return I. I found it. If I didn't, keep going and go all the way to the end. And if I ever finish that for loop and never find it, what do I know? I know it's not there. So what do? I return not found. Now we all know not found is really just -1, but not found is a little bit more self-descriptive than -1. So that's why we were using that constant there. So there's our linear search. Any questions about that? Yeah.
Yeah, I remember that with what we were doing yesterday, there was another function that we used. I think it was index of, and I was wondering why we have this.
Well, we're not making an index of right now. There's no index of in here.
Now, but I was just wondering what's the difference in having a find function that's private and then the index of thing, which is.
Well, that's a difficult one to answer because it depends on what you want your object to do, right? This one we don't have an index of, so there's no need for an index of. Now, if I wanted an index of, and you're like, well, you've just got to find, well, yeah, okay, then I can call this index of and make it public if I wanted it to. Or what you could say is, and sometimes this happens, is you might have 2 versions of the same method. One that returns a sentinel value, and one that might throw an exception if it doesn't exist. Why? Well, it depends on what you want to do. So it's hard to answer questions like this because it always comes down to well, what do you want to do? Do you want it to work that way or not? Yeah. Yeah. Don't get me wrong, it's a fair enough question, but the answer I'm telling you is going to be unsatisfying because it really does come down to well, what do you want to do? And then contains. Well, contains returns a Boolean. Does it exist or not? Well, we already have find, so if find gives me anything that's not found, return the result of this expression. If it returns if it returns -1, does -1 not equal -1? False. It returns false. Any other case, this returns any value that's not -1. It returns true. So contains just hijacks that private method. Awesome. Great. Okay. Oh, look at that. There is an index of. Oh, I guess we did want an index of. I don't know why we want an index of. I just went on a rant about why there's no utility in knowing the index of any of these things, but I guess I decided to add one because why not? So we want to know the index of a friend, but what do we do if it doesn't exist? Do we return a -1? We could. We could do a -1, right? We could return that sentinel value. But often, depending on how things are designed, like we could say, well, if someone's using this class correctly, and this all comes down to what I was just saying. It really depends on, well, what do you want to do? So I'm envisioning a world where like someone really shouldn't be asking to get the index of something that doesn't exist. And if they do ask for the index of something that doesn't exist, raise an exception, throw an exception. That means you're using this in a weird way. You got to deal with it. So what I say is, hey, do I not contain this thing? If that's the case, throw a no such element exception, and then in there I say objects.toString friend. What's going on there? Well, when you throw an exception can take an argument. That'll be a string. And often it's nice to have a descriptive string in your exception that says like what went wrong. You see these, if you've raised your hand if you wrote some Java code and you got an exception. Come on, don't lie. Right? That just means you haven't done assignment 1 yet, right? So if you work through assignment 1 and you see an exception, sometimes it'll be like, there's no such thing as index 7, right? That would be the string that was in the exception. So this no such element exception, we're taking the string of that friend. Now, you're like, hold on, when I call the toString on a friend, I would say like friend.toString. Why am I saying objects.toString? Who wants to take a wild guess? Null safe, exactly. Because if someone put in null here, it would crash the whole program. If someone put in null here, if it's objects.toString, first it says, are you null? And then it carries on just fine. That's all. Does it strictly really need to be like that? No, but should it be? Yeah, it's definitely a lot better and safer to do your code that way using those object static methods. Again, it's just a wrapper method. It basically, if we go look at objects.toString, I'm willing to bet it's, are you null? And if you are, it probably returns null or something, like the string null. Otherwise, or else, return the friend.toString. Let's check for fun. Let's see what it actually looks like. No, I can't. No, objects. What was it? String.value of, oh. There we go. Is it null? If it is, this is some funny inline syntax for like if then else. If this is true, return this, else this. It's an inline, it's called tertiary, something like that. It's a quick and easy like line to do like an if then else on a single line of code. I don't love it in general, but you know, it comes in handy. And look, it was exactly what I expected it to be. Are you null? If it is, return the string null. Otherwise, return whatever the object is .toString. That's all. It's just a wrapper. We call those like wrappers. So index of, it says if it doesn't exist, throw the exception. If it does exist, return the result of find. There we go. Cool. Isn't that great? We already have a find. So there's a better answer to your question. I guess in a case where you really want it, that's how you would do it.
Yeah, I'm looking at the code and it's like, if you tried to program it in a way so that you only had the index of instead of the find function that you guys have code that basically loops into itself and causes problems?
So it also wouldn't be, there are some collections out there where both versions would be public, where one has a sentinel value and one has an exception. That's not uncommon, but for what we're doing, we're designing it this way because. Cool. All right. See y'all later.